In this video, we are going to look at some example of counting permutation. Example 1. Find the number of ways to arrange the letters from the word best when repetition is not allowed. How can we solve this question? Okay, first, let's form 4 slots for 4 letters. Look at the first slot. In how many ways can we fill the first slot? We can fill it with any of the 4 letters, right? We can fill it with P, E, S, or T. Hence, there are 4 ways to fill the first slot. Now, look at the second slot. We ask the same question. How many ways can we fill the second slot? Remember that repetition is not allowed. Let's go one by one. If we fill the first slot with P, which letter can we fill in the second slot so that repetition won't happen? Yes, we can fill the second slot with E, S, or T. What if we fill the first slot with E? Then we can fill the second slot with P, S, or T. What if we fill the first slot with S? Then we can fill the first slot with P, E, or T. And what if we fill the first slot with T? Then we can fill the second slot with B, E, or S. We observed that for each letter in first slot, there are 3 ways to fill the second slot. Now look at the third slot. How many ways to fill the third slot? Pause this video and try to answer. Now that we have used 2 letters for the first and second slot, we are left with 2 more letters for the third slot. Hence, there are 2 ways to fill the third slot. Up until now, we have used 3 letters to fill the first, second, and third slot. How many letters are left for the fourth slot? Yes, 1 letter. Hence, there is only 1 way to fill the fourth slot. Now we are done with all slots. What should we do next? Of course, we are going to find the number of ways to fill all 4 slots. That is, how many ways to fill the first slot, and second slots, and third slot, and fourth slot. That means we need to apply rule of product. So, 4 ways times 3 ways times 2 ways times 1 way. Therefore, there are 24 ways to arrange the letters. But hold up! Actually, 4 times 3 times 2 times 1 can be written as this. This is 4 factorial. Now what is factorial? It is easy. For a positive integer n factorial is the product of n minus 1, n minus 2, up until 2 and then 1. For example just now, 4 factorial. It is the product of 4, 3, 2, and 1, which we get 24. 6 factorial. It is the product of 6, 5, 4, 3, 2, and 1, which is 720. Now from example 1, we have a result, which is the number of permutations for n distinct objects is n factorial. Okay, let's move on to next example. Find the number of ways to arrange the letters of the word look. Observe that there are 2 identical letters O. How can we find the number of ways to arrange them if there are identical letters? First, let's make the 2 O's distinct by marking it as O1 and O2. Now, there is no more identical letter, right? All letters are distinct. Hence, we can use the previous result. The number of permutation for 4 distinct objects is 4 factorial. Now, let's look at the arrangement of the O's. This is how we write earlier, L, O1, O2, K. But we can rearrange the O's and becomes L, O2, O1, K. If we change back to original O, we get the same thing, L, O, O, K. Okay, now what about this arrangement? L, K, O1, O2. Reorder the O's and we get this: L, K, O2, O1. But this is the same thing: L, K, O, O. Now, I am not going to list out all arrangement because we already know that there are 4 factorial ways to arrange the letter when all letters are distinct. But when we change the O's back to identical, we notice that 2 of them give the same thing. Hence, we will divide 4 factorial with a number. What number? Yes, number of ways to arrange O1 and O2, which is 2 factorial. So then we get 4 times 3 times 2 times 1, which is 4 factorial, and then we divide it with 2 times 1, which is 2 factorial. Therefore, the answer is 12. Okay, from this example, we make a general rule. The number of permutations for n objects involving identical objects is n factorial divide a factorial, b factorial, c factorial, and so on, where a, b, c, and so on are the number of identical objects for each type.